Today you will be finding the inverse of a square matrix. So some terminology, we have the multiplicative inverse. This is a value that multiplies to an identity element. For example, we know 4 times 1/4 is 1. In the identity for square matrix, for a 2 by 2 matrix, notice from the top left to the bottom right, those are all 1s, and everywhere else this is 0. For a 3 by 3 matrix, the identity for a square matrix, again, the top left to the bottom right are all 1s, everywhere else is 0. And to find the inverse of a 2 by 2 matrix, if I have matrix A, then that means the inverse is what we'll do is we will take the diagonal AD minus the diagonal BC, right? We'll put that underneath 1, and then notice what also happens. Okay, so we will flip the position of A and D, and we will change the signs of B and C, and then it's scalar multiplication. So if we look at an example, notice we have the inverse of A, where element row 1, column 1 is -1, row 1, column 2 is -2, row 2, column 1 is 3, and row 2, column 2 is 4. So notice we have our 1 over -4 would be the product of 1 and 4 minus the product of 2 and 3, -2 and 3. And then notice we have flipped our A and D, so these values are flipped. And we've changed the signs of -2 and +3. Okay, so we know that when we simplify 1 over -4 minus a -6, we do get 1 over 2, and we still have our same matrix, and then we distribute. Here's our final answer. So in our first type of problem, we will have to verify whether or not A and B are inverses. And the way to do that, though, if we have both products are equal to the identity matrix, then the matrices are inverses. So that means we have to find the product of AB. Okay, so AB. We know A is a 2 by 2 matrix and B is a 2 by 2 matrix, so the product AB will also be a 2 by 2 matrix. And we will have row 1 as our pencil, and then we'll have the columns of B be the cups. Okay, so if I notice we will have -1 paired with 2, and -2 paired with -3 over 2. Then we will take the red row into the green column. So -1 will be paired with 1. -2 will be paired with -1/2. Okay, so then we'll take row 2 and place into the blue column and also the green column. So 3 is paired with 2. 4 is paired with -3/2. Okay. 3 is paired with 1. And 4 is paired with -1/2. Okay, so now we clean it up. So we know we have the product AB. We'll have -2 plus 3, -1 plus 1, 6 minus 6, and 3 minus 2, which gives us the identity matrix, which is what we want. Okay, so now let's do product B times A. And I don't know about you, but I don't like to look at my product backwards because sometimes I mix up the rows and columns. So I'm going to recopy A to the right of B to denote B times A. Okay, and notice this time matrix B is our row matrix, and matrix A is the column matrix. Okay, so 2 is paired with -1. 1 is paired with 3. Yellow row has to go to the red column. 2 paired with 2, negative, and then 1 paired with 4. -3/2 is paired with -1. And -1/2 is paired with 3. -3/2 is paired with 2. And -1/2 is paired with 4. So B times A, first row, -2 plus 3 and -4 plus 4. Second row, +3/2 minus 3/2, and +3 and -2, which also gives us the inverse, or the identity matrix. So we can say, yes, they're inverses. Now I would like you to take a minute or two to try the example you try. So hopefully you found the product of AB and B times A to be the identity matrix, so we can say, yes, they are inverses. So in this same example, we're doing the exact same thing, except this time we're looking at a 3x3 matrix. And remember that when I do both A times B and B times A, and we get the the identity matrix, we can say the two matrices are inverses. So if I want to find product AB, okay, that means I have a 3x3 matrix for A and a 3x3 matrix for B, so that means my result would be a 3x3 matrix. Since A comes first in the statement, and that's our row matrix, and we have 3 columns for cups, pencil in the cup. So when we find A, we know we'll have 1 times 3 plus the middle, -1 times -2 plus 1 times -4. And then I'll use the green row into the blue. 1 times -3. -1 times 2. 1 times 5. Okay, then we'll switch it up and we'll use the yellow row, 0 times 3. -2 times -2. 1 times -4. And then we'll use the blue row. I forgot to take the green row into the green column. 1 times 1, -1 times -1, 1 times -2. There we go. Okay, so yellow row into the blue column, 0 times 3, -2 times 2, 1 times 5. And then we'll take the yellow row into the green column, 0 times 1, -2 times -1, 1 times -2. Now we'll use the gray row into the red column, so -2 times 3 plus -3 times -2 plus 0 times negative 4, negative 2 times negative 3, negative 3 times 2, 0 times 5. And into the green column, negative 2 times 1 is negative 2, negative 3 times negative 1 is positive 3, and then 0. So all that's left now is for us to clean this up. Row 1 becomes 3 plus 2 minus 4. The middle, negative 3 minus 2 plus 5. The far right top, 1 plus 1 minus 2. Middle row, 0 plus 4 minus 4. For column 2, 0 minus 4 plus 5. And for column 3, 0 plus 2 minus 2. The bottom row, we have negative 6 plus 6. We have 0 and we have 1. And so when we simplify here, we will get our identity matrix. Okay, so what we'll do now is we'll do the exact same thing, except now we'll do b times a. And because I don't like looking at my rows and columns backwards, I will recopy a and then redraw my rows and columns. So if we're looking for product BA, we'll start by using our B matrix as our rows. And then that means our A matrix is the column matrix. Okay, so B times A. We will start off with our yellow row into the blue column. So 3 times 1 is 3. Negative 3 times 0 is 0. 1 times negative 2 is negative 2. Yellow row into the green column. 3 times negative 1 is negative 3. Negative 3 times negative 2 is positive 6. 1 times negative 3 is positive 3. Nope, sorry, negative 3. And then we'll take the yellow row into the yellow column. So 3 times 1 is 3. Negative 3 times 1 is negative 3. And 1 times 0 is 0. Gray column into red, or gray row into red column. Negative 2 times 1 is negative 2. 2 times 0 is 0. Negative 1 times negative 2 is positive 2. Negative 2 times negative 1 is negative 2, no, positive 2. 2 times negative 2 is negative 4. And negative 1 times negative 3 is positive 3. Yellow column, gray row. Negative 2 times 1 is negative 2. 2 times 1 is 2, and then plus 0. And then we can use the red row into each column. So red row into blue. Negative 4, 5 times 0 is 0. Negative 2 times negative 2 is positive 4. Green column. Negative 4 times negative 1 is 4. 5 times negative 2 is 10. Negative. And negative 2 times negative 3 is positive 6. And then red row into yellow column. Negative 4 times 1 is negative 4. 5 times 1 is 5. And negative 2 times 0 is 0. And then all that's left for us to do is to clean it up. So BA is going to equal 1, 0, 0. And then second row, 0, 1, 0. Third row, 0, 0, 1. So we can say, yes, they're inverse. Okay, so next thing, I want you to take a minute or two and try the example you try. And hopefully when you found products AB and BA, you do both get the identity matrix, and therefore they are inverses. Okay, so on this next problem, we are going to actually find the inverse of a square matrix. So if you have forgotten how to do that from earlier, we are going to, if I have matrix A, and matrix A equals A, B, C, D for my elements, then that means the inverse of the matrix, I'll do 1 over the diagonal AD minus the diagonal BC. We're going to flip the position of A and D and then change the signs of B and C. So that is how we will go about finding our inverse. So right away, we know the inverse of our matrix. We'll do 1 over, we'll do 2 times 4 minus 1 times -3, and then we'll switch the position of A and D. So we'll switch the position, oh no, wrong ones, of A and D, 2 and 4. And then we'll change the signs of the -3 and the 1. Okay, so when we clean this one up, we'll have the inverse of A is equal to 1 over 8 plus 3, and then, which we know to be 1/11th, and we just distribute that through. So 4/11ths, -1/11th, 3/11ths, and 2/11ths. And that's it. I want you to take a minute and try the example you tried. Time for some practice. The end.